Question?
No.
All right, number 16. It says that you have an interval from 0 to pi. What is the period of each graph? So this should be pretty simple. Right, if you look at number 16, there's 3 total cycles in view. One of them is half and half, but you can put it together to make one. And so since there's 3 complete cycles over a distance of 2 pi, then each individual one must be 2 pi
So
divided by
basically,
3.
you just look at the cycles.
Yep. And then for number 17, there's 1, 2, 3, 4 of them in the interval from 0 to 2 pi. So you would go 2 pi divided by 4, and then since you're all good math students, you would reduce that to pi over 2. Okay? Okay, then, I gave you 4 graphs to do?
Yeah.
Sorry.
It's ridiculous.
No, it's redonkulous.
Yeah, you gave us way too much stuff.
Okay, 22 starts out with your basic tangent function graph. And we're going from 0 to 2 pi. So I'm going to make some things here. All right, this one you should know. The regular old standard tangent graph has a vertical asymptote at pi over 2 and at 3 pi over 2. Okay? And it starts at 0 and goes up. And then makes this little shape here. And makes this one half of it here. Okay?
Wait.
So that's the graph of the tangent function, and you should know what that looks like generally. Okay? All right? Good for you. That you should know.
That pi over
So this graph you should have not just maybe in your homework, but also somewhere in your notes.
I think I do have
So you could, we went over this together as a class, so this one shouldn't have been a challenge. So that then you could look back and figure this one out. Okay? All right, let's do this the easy way. 23 says now we want to graph y equals the tangent of 2 theta.
Put this in a calculator.
Just expand it.
No, we're not doing this on the calculator. How does that change your graph? What is the period of it now?
It's double.
No. The old period
Oh,
was
it's half. It's
pi.
only pi.
Now since there's a 2 in front, it's going to be pi over 2. Okay? So that means it's squished. You don't get it?
I don't get it.
I thought we could cheat our way through this and do it the easy way.
I got it.
All right.
What?
So we're trying to graph y equals tangent of 2 theta this time. And we still need to go from 0 to 2 pi.
Is it 4 pi? Why wouldn't it?
Well, because they want us to still always go from 0 to 2 pi. So our scale is going to be the same, 0 to 2 pi. What is the period of this function? Pi over 2. The period of the original tangent function is pi. So since there's a 2 now in front of the variable, my new period is going to be pi over 2. It's the exact same thing as we did with the sine and the cosine. The period of a sine and cosine function is 2 pi. So if you throw a 3 in front of there, it's 2 pi over 3. Okay? So that means that, here's the tricky part, if the period of this function is pi over 2, the, what's that called, scale or whatever, I want to go half of that, so I want to go pi over 4. So I'm going to go by pi over 4 is here. So pi over 4, pi over 2, 3 pi over 4, then pi, then 5 pi over 4, then 3 pi over 2, then 7 pi over 4. Okay? So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Just some of them get reduced. Some of them get. Katie, since you raised your hand. I don't reward blurters. What?
Why is it pi over 6? Shouldn't it just be pi because we like 2 pi over
No, because cotangent you divide, it's the original function as a period of pi. So you divide pi by 2. So that's a confusing thing. Sine and cosine is 2 pi over b. Tangent is just pi. Okay? All right, so once you have this part figured out, which I understand that a lot of you don't, now it's easy. Every other one is an asymptote.
Mr. Aldrich, how do you determine on the asymptote, is the farthest right always going to be down and the far left is always going to be up one?
Yeah, it's increasing.
So there's 4 things.
Which should make sense to you because if we're going at an interval from 0 to 2 pi, however 2 goes into 2 pi 4 times. So we're going to be able to get 4 complete cycles of the graph in that interval. Okay?
That's nice.
Thanks, man.
Pi over 3 in the original was 2 pi.
No, the original was pi.
Pi.
So my new, the b here is 2 pi over 3. So I have to go, I have to go pi divided by 2 pi over 3, which is going to be pi times 3 over 2 pi. So those cross out, and so my period of this is 3/2. Okay? Which is 1.5, right?
Can we write that as 1.5 instead of
Sure.
like fraction?
And so since my period is
3/2.
3/2, I'm going to go by half of that,
0.75.
which is 3/4.
Aldrich, we're going to try and remember you to do that.
You want to go decimal?
Why?
Please. Okay, so 0.75, 1.5, 2.25, 3.
3.75.
And I'm not going to make it all the way to 2 pi because 2 pi is a little bit more than 6.
Yeah, that's a lot.
So 4.5.
Could have just done back.
Still would have been the same thing, really.
This is 5.25, right?
Yeah.
This is 6. So let's just call that 2 pi plus 1. And so I've got an asymptote here, an asymptote here, an asymptote here, and an asymptote here.
Oh, I did this one.
The next one, how do you put that?
Like flip it and multiply it.
Oh, I got it.
I knew how to.
Okay, for 25, be careful. What's the period? Be careful, think about it.
Wait. 1. Pi over 1.
Which is just pi. Okay, so b is -1. So you would go pi over -1 and get negative pi, but the period can never be negative. So the period is still
Pi.
pi. And so that means our graph is going to be pretty simple. I've got 2 pi, pi over 2, 3 pi over 2. I got an asymptote here, and I got an asymptote there. What does the negative do to the graph? Yeah, instead of starting here and going up, if it's negative, it starts here, it goes down. And these will be flipped. It looks like that.
You looked at me when I was like I was stupid when I said that. I thought it was.
Sorry. Bad teacher, sorry.
That is
I'm a bad human being. Okay? Am I going to do what?
That's full credit.
We're not done?
Yeah, we are. Let's do the whole time. Actually, he did
Oh, we need those two?
Yeah.
Did I just assign 18 and 19?
No, he did 8 through 25.
18 through 25.
No, you assigned 8 through 25. Oh, yeah.
Okay, 18, you know where the what the period is, right? Pi over 5.
Yeah.
And so the way we can find one of the asymptotes is the first one's going to happen at half of the period.
So pi over negative 10.
Pi over 10.
And the other one's just the opposite side.
And then the next one is going to be at where the first one is plus 1 cycle.
So it's negative.
So pi over 10 plus pi over pi, which since everybody loves fractions so much, you know is pi over 10 plus 2 pi over 10, which is 3 pi over 10.
That's so.
You don't get the fraction adding?
That is not at all the answer. It's what you're talking about.
Well, if you look at these graphs, what we were doing before, our period was pi. First asymptote showed up at pi over 2, which is half of that. Right? This one, the period was 3 halves. The first asymptote showed up at 0.75, which was half of that. Okay? One more time. Period is pi over 2. First asymptote showed up at pi over 4. Okay? Katie, you said you didn't understand, and now you're not paying attention. That frustrates me. Okay? So that's how you get the first one, is you just take what the period is and cut it in half. And when you get the second one is you know that this distance is going to be equal to the period. So I go pi over 4 plus pi over 2 to get to that. Okay? And then I could, if I needed another asymptote, go plus pi over 2 again. Okay? Or this one right here, we went 0.75 plus 1.5 to get to my next asymptote.
I get it, but since the graph, like, wait, stop. No, go back to the graph. Since the first, okay, it doesn't matter which one. Like, at the first, before you hit the asymptote, that one's going half, like, including in the negative, so then it's just plus or minus.
Exactly.
Okay.
Oh, so you could do it that way too. So that's a way easier way to get the second one.
That's what I did.
Okay, so I did it more complicated way than I needed to. It turns out the first asymptote is at pi over 10. I found the next one by adding 1 period onto that and got 3 pi over 10. But Forrest is pointing out that if the first one is at positive pi over 10, then there's going to be one before it at negative pi over 10.
Woo! I don't really understand like how the heck that 3 pi.
Make it negative.
Do you understand why I did pi over 10 plus pi over 5?
Yeah, and then like
Okay,
I
so
can
the
see-
common denominator is 10.
Yeah.
So I had to multiply the 5 by 2 to get 10.
Okay,
So I have to multiply the top by 2, okay? Okay, so Forrest's little trick is going to make the rest of these easy. So I will only do number 19 with you, and then you can turn those in. So if I have the tangent of 3 halves theta, then my period is going to be pi over 3 halves, which means I have to invert and multiply, which means it's going to be 2 pi over 3. So that's the first part of the question is, hold on, shh. What?
Okay, so how did you get pi over 4?
Because this right here is 3 over 2, and it's always going to be pi over that, whatever this is. Okay? So now, so that's the period. So now to find my first asymptote, I just have to take the period and cut it in half. What's half of 2 pi over 3? 1 pi over 3. And then like Forrest said, there's also going to be one at negative pi over 3, and we're good. Okay? All right, so finish up 20 and 21 if you still need to, and then pass.